Hello, brothers, and welcome to this explainer. I'm speaking directly to you today, the wastewater operators, the shift managers, the absolute frontline defenders of our plants. We're tackling a really critical shift brief right now. We are looking at Incident 9, oil, grease, and hydrocarbon overload. Look, as operators, we all know the harsh reality, right? When our physical and chemical treatments fail, it's our biology that pays the ultimate price. So grab your clipboards, get settled, because I'm going to walk you through exactly how to recognize, investigate, and completely defeat this crisis. Okay, let's dive right into this.
Paint this nightmare scenario with me for a second. You walk out of the control room, you look out over the plant overview, and you stare down at your biological aeration basins. But instead of a healthy churning mix, you see just a total mess. A thick, suffocating, stable brown foam is literally taking over the plant. When our dissolved air flotation, our DAF, underperforms, all that oil and grease spills right over. And brothers, let me tell you, a hydrocarbon shock to our biology is for sure one of the most severe emergencies we can ever face.
But hey, don't panic. We have a highly structured, foolproof triage plan to diagnose and beat this thing together. Today, we're going to quickly cover symptoms of ONG overload, identifying those root causes, the investigation procedure, scenario-based action plans, our emergency on-site checklist, and finally, some key takeaways.
Section 1. Symptoms of ONG overload.
Now, the very first step in any crisis is validating the severity by recognizing the physical symptoms right out there on the floor, because you obviously can't fix what you haven't diagnosed. Out in the clarifier basin, you might start noticing this thick rainbow film, or just chunks of floating brown grease. But when you get down to the microscopic level, the proof is right there. Our biomass is getting completely coated in a lipid layer. This physically blocks the exchange of oxygen and carbon dioxide, which causes the localized death of our good bacteria and simultaneously triggers this massive, explosive growth of oil-loving filamentous bacteria, like Nocardia.
So, keeping your checklist of symptoms top of mind is absolutely crucial. You're going to see that rainbow film building up on the DAF. You'll spot that stubborn brown or black foam building up past 10, maybe even 30 centimeters on the aeration tank. And we're talking about foam that won't even break apart when you blast it with a water hose. You'll also notice your effluent COD, BOD, and total suspended solids just skyrocketing. Your sludge volume index will start creeping up as those filamentous bacteria take over, and your dissolved oxygen sensors, well, they'll start spitting out muffled, totally erratic readings because that oil is literally blinding the membranes.
Section 2. Identifying root causes.
Okay, so once we spot those symptoms, we kind of need to treat the plant like a patient to find the actual underlying disease, right? Let's break down the usual suspects. Unauthorized batch dumps from the production line, like someone dumping waste oil or running a massive clean-in-place process, are a huge primary culprit. You'll usually catch a batch dump by a sudden, crazy spike in ONG and really rapid pH shifts. Then, of course, we have DAF system failures, where our chemicals or air pressure are just completely off. We also run into clogged separators, emulsified oils caused by wild pH levels or low temps, and sometimes it's just a plain old hydraulic overload.
And honestly, this is where the battle is really won or lost. The failure almost always begins right at our physical barriers. The moment our massive industrial separation tanks or our mechanical skimmers get overwhelmed or just mechanically fail, well, the oil entirely bypasses our primary defense and marches straight into the biological stage.
Section 3. The investigation procedure.
So when that alarm sounds and you see that foam, we don't just stand around guessing. We move into a systematic, step-by-step investigation. Brothers, I need you to follow these exact steps to pinpoint the breach. First, pull your samples to find exactly where the system broke down. Next, check your DAF pressures and your pH. We really want that pH sitting right in that sweet spot between 6.5 and 7.5. Third, get that sludge under a microscope ASAP to look for those nasty, oil-loving filamentous bacteria. And finally, go trace the production logbooks. March over to the factory side and find out exactly what they dumped and when they dumped it.
You've got to get out there with your auto samplers and pull the hard data. Run some rapid jar tests so you can visually confirm exactly where the chemical separation is failing. Like, are you lacking coagulant? Is the flocculant just refusing to bind? A proper jar test is going to give you the answer in minutes, not hours.
And whatever you do, don't forget your instrumentation. Remember, an oil layer suffocates everything it touches. You must physically wipe down those DO sensors and recalibrate them. After that, check the biological respiration using a respirometer if you've got one handy. We desperately need to know just how badly our bacteria are struggling to breathe under that heavy lipid coating.
Section 4. Scenario-based action plans.
So once the root cause is confirmed, we shift gears from diagnosis to full-on surgery. We immediately execute our scenario-based action plans. Here is the exact triage for batch dumps and DAF failures. If you're dealing with a batch dump, in those first 4 hours, you cut the flow immediately if you have a bypass, and you manually skim like your life literally depends on it. In the short term, get your polymer doses optimized. Now, for a DAF failure, drop the incoming flow to 70 or 80% of your design capacity right away. Give the mechanicals some breathing room to catch up, and stabilize your system.
Now, things get a bit more complicated when we face emulsified oils. If the oil is tightly bound in the water and simply refuses to float, you absolutely must run lab-scale demulsifier tests in your cylinders. You have to find the correct chemical break before that sticky, stubborn emulsion completely clogs up our entire piping and manifold network.
So, for that emulsified oil, your emergency action plan is to carefully adjust the pH and hit it hard with the demulsifier. On the other hand, if you're dealing with a massive nocardia foam outbreak, direct your team to aggressively skim it off. But listen to me carefully here. Whatever you do, do not return that skim back into the system. It is packed full of bad bacteria. You must waste that infected sludge out of the system entirely by increasing your waste-activated sludge rate to lower your overall sludge age.
And you really need to emphasize to your plant owners that long-term survival here requires real investment. We absolutely need active SCADA monitoring so we can catch pressure drops before they snowball into full-blown disasters. Plus, we need upgraded, reliable chemical dosing panels to automatically adjust our coagulants and demulsifiers so we never have to face a repeat incident.
Section 5. Emergency On-Site Checklist.
Brothers, when those sirens go off, human error instantly becomes our biggest enemy. That's exactly why I want to highlight the single most important tool for any shift lead, the Emergency On-Site Checklist. Seriously, print this out right now. Put it on a clipboard. Instruct your operators to physically check off these items in the heat of the moment. Measure the oil, verify the air, run the jar test, check the microscope, skim the foam, clean the DO sensor, trace the logs, evaluate the oil type, increase the wasting, log the incident. Ensuring that not a single critical step is missed is exactly how we save the plant.
Remind your teams that by strictly monitoring and controlling that influent flume, we are fiercely protecting our true frontline workers, the hard-working, healthy bacteria living in our aeration basins. If we get lazy and let our guard down at the headworks, the biology dies and the whole plant fails. It's really that simple.
Section 6. Final takeaways for operators.
Let's bring this briefing to a close by grounding ourselves in the core philosophies of wastewater management. Just as all the great engineering manuals teach us, a beautiful, crystal-clear clarifier is only ever possible when our physical front lines hold strong. We absolutely cannot allow the O&G concentration entering the biological basin to exceed 15 to 20 milligrams per liter. I'm telling you, once you actually see that thick foam appear, it's already a late warning sign.
And that brings us directly to the golden rule of industrial wastewater. Read this one with me and really let it sink in. Source control is always more effective than treating the consequences. Catching the oil right at the production line, long before it ever has a chance to hit the biology, has to be our ultimate goal. We must partner up with the production teams to stop these batch dumps before they even start.
I'll leave you with this provocative thought to take back to the control room today. Is your planet's frontline DAF defense truly ready to handle the next batch dump? Challenge yourselves, brothers. Get back out on the floor, inspect those skimmers, check your chemical supplies, and verify your defensive readiness right now, today. Thanks for joining me on this explainer. Keep your water clean and your biology healthy.